Hello, everybody. Welcome back to 3D Hangouts. My name is Noel Ruiz. I'm a designer here at Adafruit. Joining me every week is my brother Pedro.
Good morning, everybody. I'm Pedro's Creative Tech here at Adafruit, and every week we're here to share 3D printed projects featuring electronics from Adafruit.
That's right. This is a show where we combine 3D printing and DIY electronics to make inspirational projects. Hello, everybody. Welcome to episode 415.
Oh, wow.
415.
Big jump there.
Yeah, it's a big jump. It is Wednesday, September 27th, 2023. And welcome everybody hanging out in the Discord chat room. We're hanging out there. If you'd like to join us during the chats, we're on all the different channels: Facebook, LinkedIn, YouTube, Twitch, and Periscope. So say hello, but we are highlighting the Discord chat. And we're in the live broadcast chat channel. The Discord link is discord.gg/Adafruit. Hello, everybody.
Good morning, everybody hanging out all over. I'm trying to type into Twitch, but it's telling me no.
Twitch. You can use the Discord chat if you want. There you go. Yeah. All right. We're going to get some shout outs to everybody hanging out live in the chat room. We're going to say hello to Rosin, squid.jpg are hanging out. Feel free to add any comments, GIFs, memes, all that fun stuff, and more. We have a fun show lined up for you folks. And we're going to start off with the housekeeping, which is adafruit.com/free. All the freebies, these get automatically added to your cart. Go to adafruit.com/free for all the details. I'll go through them now. This week, for orders that are $99 or more, you get a free PCB coaster with the Adafruit logo in a lovely gold finish. For orders that are $149 or more, you get a PCB coaster plus an Adafruit KB2040. That's that lovely dev board with all sorts of features packed into it. For orders that are $199 or more, you'll get the KB2040, the PCB coaster, and free UPS ground shipping for continental US only. And if your order is $299 or more, you'll get the free ground shipping, the KB2040, the PCB coaster, and the all-new Adafruit Metro M7.
What?
Partnership with DigiKey. Adafruit.com/free for all the details. No need for coupons. They automatically get added to your cart. But you could always use our coupon this week, rather today. It's Synth Guitar. Get you 10% off all items that are physical in the Adafruit shop. Check this out. Use our code and get 10% off your order. Excuse me. My coffee made me gassy.
Making sure everything's posted up on the Facebook as well. We're also on Periscope. Good morning, Charles Benaford over on the YouTube chats.
Hello.
Make sure everything is loaded up. All right, cool.
I'm loaded and ready. All right. The Synth Guitar. We've been talking about it for the past couple of weeks now. It is a big build. It is big in size and big in features. This is a super fun musical project. Huge shout out to Liz Clark for writing the code for it and helping me develop all the feature sets. It's a fully capable synthesizer. In CircuitPython, the Synth.io module is getting lots of fanfare, which is great. So thank you, everybody, for checking out and using the Synth.io module in CircuitPython. Big shout out to Jeff Epler, John Park, people from the community as well. We got Toddbot, who's been making lots of fun projects, demo code. And Liz Clark, she's been coming up with some really cool projects. And the Synth Guitar was sort of a remake of a previous MIDI controller.
Oh, we got it back there.
We got it back there. I used to have it up here. It basically uses a strum bar like the Guitar Hero game controllers. It uses that to let you strum like a guitar player. And it's using the latest stuff from Adafruit. So the NeoKey switches, they are Cherry MX compatible key switches. Are PCBs that have backlit RGB LEDs. So we're using those to play the different notes. And then we have the PropMaker Feather back in stock, by the way. It has a really nice audio amplifier that gives you really good digital audio out. So we're using that. The Rotary Encoders are Stemma QT. So they're all daisy chained together. And it makes it really easy to integrate rotary encoders in your project. So we have those. I have a couple of switches for changing up different modes. And yeah, it's a pretty big build. Lots of parts in it. But we think it's a really good example of like how robust you can make your synthesizers. I don't know if robust is the right word. I need a better word. How far out there you can make your synthesizers. They don't have to be your traditional like keyboard. We've been seeing a lot of keyboard. We like keyboards, but something in the form factor of a guitar really takes it the idea of a synthesizer like out there.
Maybe
Like that right there. Pitch's got one too. So the Learn Guide's been in the works. Last week we had it under review, and then it went live later that day. So we're gonna quickly browse through a bit through the Learn Guide and pull some things out of it and check it out. So all the parts are back in stock, just about. You got the PropMaker Feathers. This is the main hero, lovely dev board for not just props, but now musical instruments. Very cool. Lots of your choices of key switches. The KL box are the ones that we have in stock. They're really nice. They let the RGB LEDs shine through on those NeoKeys. We have a speaker. So a big part of this project is we want it to be fully contained, no MIDI controller, no attachment to a musical computer. It's all built in. So that was really important for us. We're using a NeoPixel stick to just kind of give you some visual flair. So the NeoPixel color will change depending on the note that you're playing, which is kind of fun. And then we wanted to be able to use this with actual guitar pedals and amplifiers. So we have the TRRS audio jack. It doesn't have to do audio, but we're using it to do audio. So you can do that to do line out, which allows you to record it or run it through a guitar effects pedal. So that's why we got that. And then all the various other things, the toggle switches, the rotary encoders, the 1x4 NeoKey QT PCBs. To power the whole thing, we're using alkaline AA batteries. So we wanted to be able to quickly change out those batteries instead of having to like recharge. So that's what we got going on for the power. Lots of different cables. Again, you're going to want all these Stemma QT cables because that's how you daisy chain everything. And then a handful of screws, mostly M3 and M2 and M25. So, but that's the list there for you. Lots of screws. Over to the circuit diagram, you can get an idea of how everything is daisy chained together. We are sharing grounds on a couple of the toggle switches, but mostly everything is using Stemma QT cables. So it's really nice.
There are plenty of places to grab a ground. What I like about all this.
Yeah. So yeah, I was able to use the ground pins from the various rotary encoder boards. So yeah, feel free to share grounds however you like, but this is how we have it set up. Onto the CAD files. All the STLs are oriented to print as is. We 3D printed them on our FDM printer. I'm using a Creality Ender 3, which has like a bed volume of 230 squared. I have a little thing here. Your max build size is around 230 by 184 by 21. I was going to try to send off the STL to be printed in resin. They ended up being a little pricey, and I could get them under $100, but I don't get the color options like I do with FDM or the sparkly finishes that we get with like a lot of these filaments. So I decided to just keep them printed on our printer. But folks are free to print them on their resin printers or send them to another service. But we really like how you can print this out on your printer. if you have one.
Yeah. Do some of those services, they probably do, offer like the dual extrusion, like multicolor?
I don't know. I haven't seen that in like PCBWay or JLC PCB. But we didn't really dual extrude. We have some overlays that you can print.
Mm-hmm.
Yeah.
And this overlay is just 1 layer thick, and it's on there with just some double stick tape, and it does an amazing job of keeping it on there. Yeah.
Yep. I use the same double stick. I really like the powder coated bed to get that nice texture on the parts. Here's what the back looks like. I opted to like add a little lightning bolt to let you know. It's a lot like a kid's toy when it comes to the battery cover. I wanted to have screws there so that, you know, you can't just snap fit it off. Especially if you're going to give this to a kid, you don't want them to easily get to the battery.
Yeah.
But yeah, we're using the alkaline batteries. I'm using rechargeable ones. Those work well. You can see all the different screws. But yeah, I ended up going with this nice mint color. And then you got that nice shiny purple iridescent, like it changes from purple to like a blue, which is really cool. That's why we really like filament. So you get some really cool filament these days.
There's purple. There's purple.
Yeah. I guess I might as well show a little bit off of it. So here's the PropMaker. You got a USB-C port for programming, but not recharging the battery because it's alkaline batteries. So we had to turn off the LiPo charging thing by just cutting a circuit or a trace. Here's the audio output. So if you switch between the built-in speaker and then the TRS jack, you can get some really clean audio out. So you can use that in a like a guitar effects, or if you have like, you know, GarageBand or Logic or Ableton, you can run this through an audio input and then create some, you know, pretty cool effects. So like reverbs and choruses and all the different things you want. And more importantly, you can record. So you can record it like a real guitar, which is pretty cool. And then of course the speaker in the head stock. And that's still pretty small. It's about the size of a ukulele, which is kind of cool.
Yeah, like a violin.
Or like a violin, yeah. We're using this really nice latching on-off button that's metal. And NeoKeys. I think I have my audio switch. Or my strum switch. All right. Are we both going to play together? We were talking about the Learn Guide, but now we're playing guitar. All right, we'll do a demo after the Learn Guide.
I think you were playing Rugrats earlier.
I was playing Rugrats theme, yes. Back to the CAD assembly. It's all designed in Fusion 360, but we have a step file. So if folks want to modify the design to be like CNC milled, or maybe you want to like create a template to cut it out of wood, that would be pretty cool. And then also all the parts, the electronics rather, are available too. So you can use those in a different synth if you want. That'd be cool. The PropMaker, the NeoKeys, and the Rotary encoders, all of the electronics are 3D models. So that's a really, really nice reference models for folks. You'll want to use the latest version of CircuitPython. You can grab that and install it easily by going into the bootloader mode and dragging and dropping the UF2 file to flash the firmware. On to the code. Liz did a great job commenting the code so folks can get a good idea of what they can change, namely the neopixels, the brightness, the sample rates. You can change that. You can change the volume. You can change the waveform. So there's different types of waveforms. There's a square, a triangle, and you can mix these, of course, together as well. Oh boy, what's the sawtooth? I actually changed mine from a square to a sawtooth just because I wanted to hear what that sounded like. You have the ability to change up the envelope of the amplifier, so you can make the release longer or shorter. You can change it to sustain level, the attack time. All that is adjustable, just like a real synthesizer. The LFO is using a a shine waveform to kind of give you that womp 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 feeling. You can change the rate of it here. Here in the notes, you can change the actual notes that are being played, the octave range. It's a full-blown synthesizer. All of these little knobs that you can tweak in the software are documented in the Synth.io Fundamentals guide, which I have linked in the beginning in the overview page. So folks, definitely check that out to get a better breakdown of all of the intricacies of kind of sculpting the sound that you want.
There's a lot there.
Yeah,
Was
there's a
that the one
lot.
where we had to review a little bit from John's guide?
Yeah, it's a big read, but
God,
it's a really good, if you've never done any synthesis before, it's a crash course in synthesizers. Lots of different things. You can mix all of these together as well to create a unique waveform. That's really cool. Yeah, so hopefully folks can get a kick out of that. Then in the Logic, it's basically got two different modes, using the strum mode and then free key play mode. And then the rotary encoders, there's 3 different ones. So you can adjust the tremolo, turn it on, turn it off. You can adjust the octaves, and then you can press the encoders to do different modes as well. So you have all these different levels of tweaking the sound, and you're totally free to customize it all. Yeah, like instead of having like the volume control, maybe you could adjust the waveform, so you can change between different kind of patches of sound. That'd be kind of cool. But it's all written there, and then Liz has a nice code breakdown of how the NeoKeys are mapped, the different colors, and then Synth.io, all the little parameters here, the mixer object, the loop, and then each individual encoder here. So these blocks here will just tell you, the encoders are controlling the LFO rate. You can change that. The keypad library for the various keys. And then the filter, the big deal with filter. You can do a low pass and a high pass filter by tilting the guitar up and down, which is really cool. So it's got the accelerometer driven audio effects. And then do the key mode. Just if the strum mode is turned off, you can have for kind of like a easier free play for like solos and stuff. So that's the code
mode.
Yeah, key mode, kid mode.
Yeah.
Well, I really like the guitar, the strum mode. So I got to stand up to kind of show it off a little bit. So by default, it's got the tremolo turned on. We can turn that off and on by pressing the button here in the middle encoder. When I press it again, it turns it on. And you can twist the knob to turn the rate. Slow it down. Speed it up. You can get pretty fast and pretty slow too. And then while you're holding the notes down, you can affect the note, the pitch. You can turn the volume up and down. And then you can switch to the strum mode here with changing this. So now when I press these, you have to actually switch it. So you have, like a real guitar, you have to hold down your note. The NeoPixel is changing the color depending on the note. So here's red. And then you can press the pitch button here to change the type of notes that you're playing. So before I was playing a triad, now it's a diatonic. So lots of different layers of features in there. Pretty cool. I'll keep continuing with the guide, and then we'll do another demo at the end.
It's like a demo every page.
Yeah, right. I got a demo every page. So that's the code. Check it out. Next page walks you through just wiring. since everything is kind of I2C, you want to have individual I2C addresses. So on the back of the Stemma QT boards, you'll notice that there are little address jumpers, and you'll want to jump those with a blob of solder. So we have these little annotated address jumpers, so you know exactly which one. So we're daisy chaining the two 1x4 NeoKeys together with a short Stemma QT cable and then a long Stemma QT cable. The NeoPixel stick has these pads on the back of the PCB. Basically just solder that up, and then it gets attached to the screw block terminals on the PropMaker Feather. Same thing with the rotary encoders. You'll want to jump certain addresses so that they're all daisy chained and connected nicely together. The on-off button, I'm using a variation of the 2-pin JST cables for the LED to turn on and off, and then also the on-off switch. So you have a nice pack of cables.
Yeah, one trick there is I had one end being the socket and plug, and then the other end being the reverse. So there's you can't plug them in at like powered into going into the.
That's a good point. Yep.
So
yeah, for mine, I did the Pico blade for the LED, and then the JSTPH for the on-off. That way, it's very specific. But you could also, if you have like a bunch of JST cables on hand, you might as well use those, and that's a good tip. You'll want to share ground. I really like these buttons. They're really rugged. They're made out of metal, really nicely diffused. They already have a resistor soldered into them, and then they have labels, so it's really nice. So the ground pin, you can share that with the LEDs negative pin, and that's basically what we're doing. We're setting that up, and then you'll want to use the normally closed pin. A lot of the other latching on-off buttons are normally open, which feels backwards when you use it. I know originally I was using one, and it was like you had to press it in to turn it off, but press it out.
The Rocket was the same way. The flip switch one. The exact same way. It's like, wait a minute, but don't you need to cover it before it turns on?
Yeah, isn't that weird? Yeah, so these are great because it gives you that extra pin, so you can be normally closed instead of normally open, like the others seem to be. For the Feather, we're gonna attach a couple of JST connectors to it, like the LED for the on-off button and the enable and ground pin. For the latching on-off switch, that's mainly what you get soldered to it. I always recommend testing that out, so you can test out your button with the Feather. That's what I'm doing here. For the battery, it came with a 2.1 barrel jack, so we just want to remove that and add in the 2-pin JST cable so that you can plug it into the Feather.
Is this the latest one that you received? Like this is a brand new one that you just ordered that came in?
Yeah.
Battery holder? Okay. Because the older ones, it was just, there was nothing attached to it.
Oh, really? Yeah, I think those are... Yeah, they come with the barrel jack, the ones I got. I wish they came with the JST plug.
I know, mine was bare.
Yeah. I chose this one because it's... I feel like it's a good AA battery holder that doesn't have a cover because you're kind of closing it already. You don't really need a cover. A lot of them we do have a cover, and they come with a switch, but it's just it feels like convoluted. So I felt with this one is a nice open face one.
Nice and slim too. You have only the connections you need on the shell that holds in the battery.
Yeah, it seems to be like the thinnest profile you can get for three AA's.
Yeah, even the mounting holes too, if you need those, but just using the double stick here for that.
Yeah, I'm using double stick, or the glue dots, as we call them. So we're testing that out, and then we're gonna wire up the various toggle switches for the strum mode. It's using a single pole, single throw switch, and then for switching between the speaker and the TRRS jack, we're using a double pole, double throw switch. That's basically the same toggle switch, but it's just like having two switches in one. So we got those soldered up. I got wire links for everything as well. Those become really important with a project like this. So definitely keep track of the wire links. For this one in particular, it's got like 8 inches long, but each one is going to have its own like wire length, so that's very important for this particular project. Then soldering those wires from the switch to the TRRS breakout. I really like this breakout. If I do any other audio projects, I'll be using that. And then the switches, there are 2 micro switches with the levers. That way you can actuate them. And they have labels on them as well, just like the on-off switch. So you have your common and then your signal. We're daisy chaining the ground so that they're, nice and sharing ground. And then you have 2 longer wires for the signal.
We actually have the quick connects for these.
Mm-hmm.
Like I didn't realize I had them until after I already soldered everything together.
Yeah.
Okay.
I guess you could use them.
Yeah. I was gonna go grab them real quick, but you get the
I
picture.
worry if the mount if they get in the way of the mount. I'm not sure. Maybe they don't. But just be aware of that. Give it a try, but if not, easy to disconnect it, right? These are going to be permanently in place. I don't really see needing it.
I was just for simple, just a one less, 3-4 things to solder out of it.
And then I think at the end of it, one of the wires gets in the screw block terminal, so it is kind of modular in that way.
Yeah, that's true.
But that's the main things that get wired up. It's one of those projects where you want to panel mount some things and then solder other things. But in the assembly page, we're going to set up the head and the neck with some screws and nuts. The speaker itself has really nice mounting tabs, so you can mount them directly to the speaker cover of the headstock with some longer screws and 10 millimeter long screws. That snap fits, so that's really nice. The NeoKey PCBs, they have like 4 mounting holes. So I have some built-in standoffs in the neck. You just want to make sure that the cable routes through in between those built-in standoffs and have it all coming out through the opening at the end of the neck. So we get those secured in there with some M25 screws. I didn't need to tap the standoffs, but you could do that if you'd like. I was able to tap it with the screw because the tolerances just worked out there. But that's how that is. If you haven't used the NeoKeys before, you'll be happy to know there's sockets, so you can switch out the mechanical key switch very easily. The overlays, you'll want to get that set up on the top half of the guitar. So you can stick that on there or add some glue. The little triangle is meant to be like the audio. It's like a play button. And then that little kind of notched circle is supposed to be like a strumming pick, like a guitar pick. So I figured that'd be a good way to differentiate the 2 switches. The neck is secured to the top half of the body with some long screws and some hex nuts. So there's some tabs there. So you just want to join those up together and maybe use some needle nose pliers to kind of hold the nut while you're fastening it in. But those get secured. Yeah,
if you're super careful with the drill, if you drill fast enough, the nut stays in and like tightens itself to having to holding it. But you just got to be so careful. Like the speed, it can definitely over tighten.
Yeah. Okay. Let's see. The battery cover, we're just going to stick that on with that square adhesive. These are really strong square adhesives, and they're kind of gummy and thick. So I kind of like that. So
malleable too a little bit.
Yeah, they're malleable too. That's a good point. So you can pick those up if you have some, or hot glue, whatever you find handy. And then at this point, you want to panel mount, or rather solder in the speaker into the double throw, double pole switch, because you're switching between the speaker and the TRS jack. So we'll want to get that mounted after that's been soldered. Comes with the hex nut and a washer, which allows you to tighten it down really nice, and it just kind of gives you a good friction mountage to the surface there. And then the rotary encoders, you want to make sure that they're in the right order. You could change it up, but we recommend doing it in this order, just kind of be consistent. So you want to take a look.
the stemma ports too, so they're not like running into the walls too. So
Yeah, that's a good
orientation to have
point.
it.
Right, you want to use those short stemma QT cables. The stemma QT from the NeoKeys gets attached here to this rotary encoder, and then the last rotary encoder in the daisy chain gets a really long one so that that can connect to the feather. At this point, we mount them, and now we're going to work on the single toggle switch, which controls the strumming mode. So you want to panel mount that. And then here's where I'm using one of the ground pins, whichever ground pin you like. I'm using the middle one on the rotary encoder breakout, but that's nice that you can just solder into the ground there. Next up, we're going to mount the NeoPixel stick to the NeoPixel mount. NeoPixel stick uses M2 screws because it's got kind of a small mounting hole. And then that gets attached to the bottom half. Then we have proper mounts, not proper, individual separate mounts for each of the buttons. They're kind of oriented in this, alternating order. So you want to have those set up. They're fairly long. They're 16 millimeter long screws, and then hex nuts to secure those. So you want to do that to both of them. You end up with something like this. You want to keep those orientations like that, where they're kind of facing the opposite ends. And then for the strum hinge, we have some more hardware. I just found that having it in separate pieces worked the best instead of having it all in one piece, because then you might need some supports. But I like having it in this, separate order. It becomes like if you were to print it in one piece, you run into a lot of friction so that's why they're printed flat like that, so that the little pegs from the strum bar are nice and kind of free floating. So print orientation matters here. So that's why I have them all like set up that way. But yeah, you're setting them up. You want to glue in those pegs. I just found that to kind of be the easiest way to do it.
I did not glue them in. They just stay in there. Yeah.
Oh, they stay in there? Okay.
Yeah,
Mine came out a little loose.
Huh.
You don't want it to pop out. So if your tolerances are nice and tight, that's good. If not, mine were loose. I ended up hot gluing them in place, or you could super glue it. And then assembling the strum plate to the back cover, you'll want to install the screws, lay it on top, and then kind of start piecing it together, kind of like a pizza. And then you want to put the mounts for the micro switches in. And then before securing it, you're able to flex the plate a little bit to allow the pegs of the strum bar to fit through those hinges.
Oh, you can screw in one side of them and then shift them like I don't know, it's like rotating, I guess.
Yeah.
Like angle them out of the way, stick it in, and then shift it back in. I think that's
all right.
A little bit easier than trying to pick up the whole thing and flexing it.
Oh well, I mean it's in place, yeah. Like mine's in place. Whichever way, it's right. Whichever way, like you're able to kind of squeeze it in there,
Mm-hmm.
So that's kind of what I did. And then after that, then I add the hex nuts to secure it down, so everything gets kind of sandwiched together. You have the plate, and then the mounts from the micro switches all get kind of sandwiched together with that bolt and screw.
Yeah.
All right, to set up the feather, you want to make sure to cut the trace on that LiPo charging bit. So you want to cut that with a hobby knife, but not too deep.
No, I recommend the flush cutters, because that's
the flush cutters.
Yeah, just
okay.
Put the tips right on there and then just close it and immediately.
Oh, that's a good idea. Yeah,
you don't have to sit there and sort of like whittle away at it.
Right. Yeah, I should have did that.
Yeah. A lot easier. It's just one chunk just grabs it and cuts it right off.
Yeah, that's a good idea. All right. Okay, whichever method you prefer, you want to cut the trace. The feather has its own mount, just because I felt like it could be a modular thing.
Oh yeah, because if it breaks, that's a huge piece to reprint.
Mm-hmm. Yeah, especially with standoffs that are like M25 sized. I recommend creating a separate mount, and there's just so much space in the guitar body that it just made sense. But yeah, just 2 screws, because the screw block terminal kind of covers those back mounting holes slightly. So you'll want to secure it down to that feather mount. Next up, because of the super long length of the on-off switch, I have this 3D printed washer, and I added that just to kind of elevate it so it's not like super close to the bottom half of the guitar. So that's kind of a neat method of like raising the thing up. If you have 2 hex nuts, that's good, but I realize that that it doesn't ship with 2 hex nuts. So that's why I like 3D printed the thing, and it kind of gives it a little bit of flair. You can see here in the photo, it looks kind of cool. It kind of raises it up just so that it's not smashing into the bottom half of the guitar.
This is the 16 millimeter long one?
Yeah. Yep. 60 millimeter diameter. Yeah.
Mine closed all the way.
Oh, yeah?
It must be getting smashed into the wall, though.
Maybe. Yeah.
I didn't
Yeah,
realize.
when I looked at it in CAD, it looked like it would not fit. So I ended up doing that. But yeah, maybe it fits. I didn't for me, so maybe you could bend the pins a little bit.
Maybe that's what happened. It got bent on its own.
Okay. Well, be careful. So at this point, we got a lot of things attached and mounted, connected. It's a bit of a checkpoint just to make sure that all your cables are nice and kind of adaptable, if that makes sense. You know what I mean? Like you want to make sure that you're
there's room. There's nothing like all
there's nothing
up on itself.
It's just a lot of components. So
yeah, right here's where I started taking the electrical tape and like bundling wires together.
Yeah, that's a good idea. Definitely. Yeah, because it gets pretty hairy down the line.
You're gonna need it for closing it.
Oh yeah, we're gonna get there. At this point, we want to secure the feather mount to the bottom half of the guitar with some screws and nuts. So we got that going on. And then just make sure that your wires are still good. At this point, we can not panel mount, but like secure the audio jack to its little spot. It's got built-in standoffs too. I just felt like it was an easy way to kind of add it to the thing.
That's like
they're pretty big standoffs. It's more of like a ledge. So they're really integrated into like the body of the guitar. So I don't feel like they're gonna break off.
No.
Yeah, like it's not a separate
one block.
It's like one block
ramp.
Yeah.
So that's not going anywhere.
Yeah, it's not going anywhere. So I felt that was good. So M2 screws, just because the TRS jack has really small diameter mounting holes. So you're gonna want to use those M2 screws. And again, I just tapped the screw holes with the screws themselves. That ended up working okay. And then at this point, we're going to want to solder in these. I'm using the 3-pin Pico Blade cable because they're really low profile, and you're going to want to be able to disconnect it when you're closing the 2 halves of the guitar. And this one's used for the interrupt pins, so it needs those interrupt pins to interrupt the code when you're twisting the knobs, because you're going to be playing a note and you want to be able to use an interrupt to like change the note on the fly. So that's how it's working. It's using those interrupt pins. And then we'll attach the other corresponding connector to the feather using the digital pins, connect them together. And then at this point, we're going to start attaching things. So we're going to plug in the stemma QT cable from the daisy chained components to the onboard stemma QT port, which is awesome. I'm so glad that this feather has that. All the feathers are starting to have that, which is really nice. So that gets plugged in. And then we'll just make sure that we're going to get a ground from the strum switch to one of the available ground pins on the breakouts. And then we're going to connect the button with the 2 JST connectors, the Pico Blade one and the PH connector. I'll get plugged in. Then we're going to start screwing things into the screw block terminal of the feather PropMaker. So we'll start off with the strum switches, and then the NeoPixel, then the TRS jack, which is the speaker, but also the jack. And then we're going to connect the battery. We're going to secure that into place. We'll plug in the battery to the battery port on the feather, and now we can start closing it up. It's kind of hard to get this photo, right? But you can kind of see how my wires are, I could have probably used some, would you say electrical tape?
It's electrical tape, yeah. So you
shrink.
stretch it so that it's like nice and like it gets thinner.
Oh yeah.
And then you cut that off, a little piece of it, and when you put it on your tape, you like wind it up in there, it like starts to like unstretch, so it like pulls it and makes it taut, so it like shrinks it.
Yeah, that's a good idea. So if you're a neat freak, you definitely go that
You're gonna
route.
need it for just
Yeah.
for coiling up the wires and moving that out of the way of the strum, and like putting them underneath the NeoPixel stick. So when the wires that come off the neck, you want to like route them underneath the NeoPixel stick.
Yeah,
And,
or
like,
you could
around the
I guess
standoff.
you could also hot glue it in place if you want.
I mean, if you have to debug and like open it up,
it could be a little problematic. So yeah, that's one of the reasons why I didn't like. I wanted everything to be still modular. But whatever route you go, be very careful with the wires. Make sure they're out of the way of the strum mechanism, because I ran into that. And just massage it as you're closing it. Just kind of use some tweezers to kind of move wires in there as you're closing it.
Yeah, even at like on the last close, push them out of the way so they're not getting stuck on the lip part.
Yeah, I got them pinching too at some points. It's like, oh man.
Even before getting the screws in, I would take the screwdriver and push it all the way through to make sure it's like not hitting a screw or a cable, a standoff. Yeah, a cable that like got in the middle of the standoff. So like poke all of your holes and make sure there's no wires in the way.
Yep.
So you don't like screw it right into your wire.
Yeah, exactly. But once you got that, then we're going to use a bunch of screws, 8 of them, to really, really secure the two halves together. Like the last guitar project had snap fits, and that tends to fall apart a lot of the times. So I really wanted...
Yeah, with something as big as that, with weight on it, it will deform.
It's just something about like the neck, putting pressure on the neck and the body that like just snap fits it open. So that's why I wanted to avoid snap fits on the main body. But I still have snap fits, for the speaker cover and the neck.
Yeah, like I'm saying, it's the weight, I believe.
Really is the weight
on it, yeah.
The weight and the pressure being applied to it. So now we're going to install these Kale switches. Do you want them clicky? Do you want them silent? It's up to you. I think there's also low profile ones, not the chalk ones, because chalks just have a different pin layout. But there are like some Gateron switches that I wanted to try out, but I didn't get enough time to try those out. But other way, you can pick your flavor of Kale, and you'll want to install the neck cover first. There's only one way to put it because it's like slightly being tapered. So just snap fit on, and then be very careful when you snap fit the key switches into the key slots. I actually turned it on. I have the guitar on when I'm attaching and press fitting the key switches, because then I know that it's actually working right. But if you go straight down, it's gonna the pins won't bend, so that's good. But if they do bend, which I have done, you can always unbend them with some
take the pliers, the needle nose pliers, and sort of flatten them out.
Yep, we have these really nice DSA, I think they're called, keycaps that are translucent, so it really lets the light shine through, the NeoPixels shine through. So you just press fit those in, and these look those are good. That's pretty much it. You want to turn it on with the on-off button, and make sure that the audio mode is going through the speaker, and the strum mode is turned off or on, depending on how you want to play it. And that's kind of the whole build. You could always plug it in through USB to debug it, to make sure everything's working. I have this little cheat sheet with an overlay, annotations of like all the various, modes. So you have volume, LFO rate, and the octaves, the audio mode, strum mode, the on and off switch. So just a little breakdown here of the usage. And then of course the accelerometer, which is, turning it up and down. And that is the whole Learn Guide. It took the whole show.
Intense. That's huge. And then so big, man.
Yeah,
definitely a expert level build.
That's why we labeled it as such. We said expert.
The battery has lasted this entire time. So it's been 2 weeks or something like that. I have not switched these out yet. And both the kids have been sitting there playing with it nonstop. We filmed all the footage with it. Like, it's still going. And they're just the rechargeable Amazon AA batteries.
Yeah, these are the same ones.
Super easy to recharge those. play. You get that raspiness.
Yeah, so I did change the waveform
Oh,
on
that's right.
mine to a sawtooth, and a sawtooth is what it sounds like. It's like,
So I'm guessing that next one be version 3 or version 4, right? The next iteration of this is going to have a little screen so you can go between all the different.
go through the patches. Yeah, right.
Exactly,
Yeah, that could be a really fun one. Yeah.
Because I was thinking that the whole time you're going through the code, showing what you can switch over to. And I was like, oh wow, if there was a screen on there with another little, rotary button to push in and change what mode you're in.
Yeah, that would be really cool.
Logical next version upgrade, I guess.
Yep.
Oh, one thing too, when you're for storage and stuff, I kept laying mine down and it would mess with the neck. So don't lay it down flat like that because of the way the neck goes down. Lay it down on the side. It is
really,
yeah, because otherwise you're applying pressure on the neck part because of where the speaker is. See, it's not completely flat. It actually goes lower than what this is. So I would, when you're placing it, on the table or whatever for storage, always have it sideways.
Yep. Or there's guitar stands as well. Like a little one for the ukulele would work well.
That would be better.
Because the design doesn't really stand up like this.
No.
But what I have is a Scottish IKEA pegboard.
Yeah.
And I have my own like little hanger thing. So if you want to, make your own, you can hang it like a real guitar would be hung. So it's basically just like a little hook, and it just sits in like that. Yeah.
Someone says that they're gonna work on building their guitar, and they want to add a theremin in the neck.
Oh wow,
that'd be pretty cool.
Yeah, that'd be cool. Yeah, we just like key switches. They're fun. They're really nice to click, to press.
And someone on YouTube is saying, "Good idea, but for why?"
It's to showcase. It's to showcase. Making your own instrument.
Yeah, Synth.io. It's the programming that all the developers made on there to show off the music and then the different form factors. And then I don't know what toy you can buy that could do this for the kids.
Yeah, there isn't really a.
As a USB drive.
There's like that good
program it.
There's that puppy guitar, but it's not like a real synthesizer.
You can't plug it into the computer and look at the code.
Right.
You can't open it and like add stuff. You can't open up the 3D file and add another thing or change it around. That's the why.
Yeah. Why? Because we want to. All right. Do we have enough time to run through?
Oh yeah, quick. Quick. What we're prototyping, it's going to be a slimmed down version of that Synth.io in the theme of Freddy Fazbear or Five Nights at Freddy. It's the little Fraz Wrench. So this is just going to be a little slimmed down synth little guy, I guess. So pushing the buttons, it'll like activate some sort of sound. And then you have the little scroll wheel, the character LCD display on there with the stemma little backpack on there. It's going to make it so enjoyable to use. And of course, PropMaker will go off the side. So you can just plug that guy right in. And then little speakers and some NeoPixels in here to give you, I guess, some sort of animation on when you're pushing, making your little buttons. The antennas will come out of here. And I don't know, I wanted to make this little grip into like a button, but the kid's like, I don't need that. So
really?
Whatever. It simplifies building it, but that's what it looks like there. It is the tool that is used in the video game for unlocking doors.
Yeah, like plugs into these like TVs.
Yeah. So there you go. It's like the main plot device for the video game.
Yeah.
I guess.
This is the fandom.com. Here's a photo of, I guess, somebody who had it as a promotional item for whatever game thing. That's kind of cool. Better cover in the back there. Looks really cool. Looks so nice and weathered and stuff. So
I'll do some vinyl stickers or something on there.
Yeah. So it's a tool used from Fazbear technicians at the Pizzaplex. It's like a thing to open doors and solve puzzles. It's pretty cool. We want to make it so that it's like it's kind of like a little synthesizer. I think it'd be cool to play different patterns, And then the screen will display the pattern that you're playing. Scroll wheel will let you change different patterns, and then the buttons can be used to turn it on, turn it off.
Yeah, I'm gonna definitely lean on you for what a synthesizer like this should do, like the operation to explain to Liz the code, because I have no idea.
Yeah,
it's like a
and like I got the idea. Like you're gonna design the case and make it all nice and buildable.
Yeah, I think one of the things that Gavin said though, when you were talking about having the display show what like patch you're on or whatever, when it goes into like after, I don't know, like a minute or so, like idle mode, if there's a way to do that, just have it say
I think so.
nodes left. I guess that's the thing in the video game.
Oh, okay. So tie in
that in
game stuff. Yeah,
nodes left, NODES, nodes left.
Yeah,
I guess that's how many doors you have to open. I don't know.
Yeah, I'll watch. I haven't played the game, but I'll watch a
idea either.
I'll probably watch a YouTube video of someone explaining and using the device, and then we'll try to maybe gamify it a little bit, where it kind of matches the game.
I wouldn't go too complex with it.
No, but
button, mod wheel, display, play audio.
Yeah.
Do a little NeoPixel animation for the button being pushed.
Yeah. Okay. Yep. So that is in the works. It's on the dock.
All right, cool. And then real quick, jumping over to the community makes.
Yep.
Timelapse camera. Yeah, this week's Timelapse Tuesday.
It's a boat.
Gonna be on point with everybody's like in One Piece, the live action adaptation. Oh, I didn't even load my camera. I'm showing it off right here.
Okay, let's take a look.
So this is, I guess, their first or their second boat that they come up with.
Really? I thought it was their first boat.
I think it's their second. The first boat, I think, was Nami's, the one she stole. But I don't know if that's, directly.
I haven't seen the anime. I've only seen the live action. So to me, it's their first one.
That's all I've seen, the live action. The first one they have was some boat that Nami stole. Remember, it sinks. Then they find Usopp and they get this Going Merry, which is model after that one dude that gets swiped, the goat guy.
Oh, that's right.
Yeah, so it's just painted and then drawn in with some Sharpie markers.
Yeah,
and it's supposed to be a planter. So take out this fake succulent, and there you can see that it has little holes for drainage. An excellent little model. I think this was free, and the designer here, Harvin, he says that he did not print this. I thought this was a print. This is just a render.
The render?
All these are just renders, yeah. I was looking at it going, oh man, that's some really good weathering on that.
Yeah.
The wood.
Yeah, it's a good render. So,
but it has not tested it out.
Yeah, we'll have to post a make because no one's made it yet.
Yeah, I know. I need to post it.
Yeah. So Henri Tavares modeled it up. Oh, it's got the little guns too, the little cannons.
Yeah.
A lot of detail, and it's
how much detail?
It prints in one piece. Get the joke? I got the joke. Yeah, so it's got drainage holes. Very nice drainage holes.
The cool thing about this, if you load up, good thing you put up the video at least.
Yeah, what's up?
The one I want to show off is, is it going to play?
Yes.
Is it playing? I don't see it playing.
It is stuck.
Oh no. I wanted to show off the tree supports. Finally used tree supports. It was the only way to get the least amount of material, and just the top part of his little chinny chin right here, and all of the underneath the I don't know what this is called on ships. Did an excellent job of getting the tree supports inside all of these tiny little underside of that.
All right, here it goes.
There it goes. Yeah, you can see the tree supports here. I keep trying to use it because I see everybody using it.
Me too.
And for this instance, it finally worked the best instead of the default ones. See how it's like going around underneath the horns.
Yeah,
I was able to catch all of that.
Sweet.
But yeah, the tree sports definitely was awesome.
That's great.
I think I did like for the density on it, it was I think like 0% for the density of the tree supports. And they came off really good.
Very nice.
I'm using it on more stuff.
Yeah.
But usually,
something
sometimes
like
it just doesn't
Sure.
make sense. Like in terms of the print time and the way that it's trying to generate them, the default supports usually work just as well. But for this particular one, it was really good.
No.
I'll be checking it out more.
Are you gonna put a real plant in it?
I think all my plants are too big.
Right. Yeah. It's not enough
Every
room.
single one of them are way bigger than this now. Like even my my pinguiculeras, which is kind of looks like a succulent.
Yeah.
It's a gigatine, so you can tell by the name, Giga. It's
got big roots.
It's already big. No, it doesn't have big roots. The leaves are just big.
Oh, right.
It's a carnivorous plant, so you touch it, like all the leaves are sticky, so I don't want to really mess with it.
Yeah, it's a cool little device or planner /
for
desk organizer.
Oh yeah.
Put your phone in there or something.
Yeah. Nice little model. Excellent job.
Yeah, free on Thingiverse.
Yes.
Shout out to Henri. Really good modeling. All right. We got 4 minutes. I'm going to run through the rest of the community makes. First up, it is still Halloween season.
It's about to be August.
It's about to actually be
October.
Yeah. So Michael D posted up his make of the Pumpkin Skull remix that we did with LED eyes. Looking good. Very, very good model there. Yep. So it looks really good. After that, we have an iPhone 13 Pro case printed in, I think, flexible material.
Oh, man, I feel bad I didn't do the 15 this year.
Really? I'm sure
every year we do one. This year I actually just bought a case.
Yeah, this is a TPU material.
Yeah.
So
you're definitely going to need this breathable type of case, though. Going forward.
Okay. After that, that was posted by David Phillip Oyster. So after that, we got a heat press from Martin on printables. Hey. They're enjoying their heat press insert rig. Nice. Looks really nice and orange, and the black aluminum extrusion looks really good. If folks don't know, this helps you do really nice heat press inserts, or heat set inserts rather, using these heat set inserts.
Yeah, it makes it nice and straight, because after a while of doing these, you're going to start to get a little crooked.
Yep. And then the last one this week is a Nefertiti bust. What? Looks like they got their kid working on helping him take it off the bed. Printed upside down. Yeah. Which I haven't seen yet, but works well for the chin.
Yeah.
So that's a good idea. I haven't actually tried that. Printed upside down with no supports. Only issue was the top of the ear. Okay. Very nice. And that is all this week's community makes. Thank you, everybody, for posting your makes.
Very awesome.
And we got a couple of fun gifts. guitars, all the guitars. Thanks, Yanni.
Maybe that'll be version 4?
Yeah.
Having multiple necks. And Yanni's saying that each neck has a different profile for it. So one can be a bass, one can be a guitar. It's like, okay, that makes sense.
All good ideas. Yeah.
Make it in the Sonic shape.
With the spikes. Yeah, it's cool. Very cool. All right. Well, don't forget, coupon code today is Synth Guitar. We'll get you 10% off anything like the PropMaker Feather, which is back in stock.
Hey. Oh, man, I was scared. I
know. I was like, it's been out for 2 weeks.
I know, because of the way I don't like reuse. When I have a board for like the photos and stuff, I usually have one in different rooms, and I thought I was out, but I went around, collect them all.
Nice. Yeah. I need to grab them for this next HAL 9000 project that I'm still working on.
I need to order more before they run out.
Yeah. Hey, almost under the ice cream. Time for ice cream.
Every time it goes by here, like we miss it.
Oh, really? Oh. Yeah, you'll get it. It's still hot out there.
What is it right now? 83. Yeah, it's hot.
Up here it's 62. So
it's been like 72 in the morning.
Oh, really?
Yeah, it was like 65 for like 2 days.
So much different up here. I said so much different up here. It's like 62 throughout the whole day with the sun.
It is so humid. 80%.
Yeah, it's actually fall. It really does feel like a fall.
Right.
All right. What other cool stuff? Everybody's doing good. Tonight we have show and tell. Potential hosts, Lamar and Phil. Backup hosts, Liz Clark. She'll be hosting if PT and Lamar need the help. I think Ask an Engineer is back this week. Was it back last week? I think it
Yes, it was.
Canceled. Okay. Yeah, so it's on tonight, 7:30 p.m. Eastern time for show and tell, 8 p.m. Eastern time for Ask an Engineer. John Park is back this week. He's got his workshop tomorrow on Thursday.
I didn't think we can do alpha channels on here.
Yeah, we can do alpha channels for sure. Friday is Scott's or Tim deep dives.
Should put both of them in there in the little window.
Both of them. Yeah, that'd be funny. Yeah.
No, I mean, I guess Scott could be the
Blinka. All right. Let's see. I think next week we'll be working on the projects still.
Yeah, I'll probably have to put together another countdown. Halloween.
Yeah, or I could. I kind of want to do one of my
do
favorite Halloween projects, so I'll do it.
Okay.
Yeah. This time it'll be like not time lapses, but like like Halloween projects. Like I really like Tombstone and whatever other. It's a good reminder of like what did we do in the past year?
Yeah, I would go do all the old ones, so we're not like doesn't feel like we're recycling the stuff from last year.
Right.
Super old ones.
Right. Like the BioShock Little Sister syringe.
Exactly, yeah.
What else? Helmets.
There's a lot, man.
Daft Punk helmets.
10 years of it.
Yeah. All right. Well, that's going to do it for us, folks. Thanks, everybody, for joining. We'll see you folks, I think, later tonight on Show and Tell. If not, we'll see you next week. Until then, remember to make a great day. Bye, folks.
See you next week.
Woo.